Good morning, everyone. Here we're going to look at finding the 6 trig values of a function like we did last time. This time we're going to do it given a function value in a quadrant. So we're going to focus on the signs, like positive, negative signs, of the values in the different quadrants. That's one of the things we're going to look at. And we're also going to talk about, I realized last time I didn't really tell you why we were creating reference angles and using SOHCAHTOA instead of using these definitions that we had before. And so we're going to talk about the why really quickly, and that might help you understand what our main goal is here. So when you look at the unit circle, one of the really important things about the unit circle is that the radius is 1, right? So when we're actually calculating sine, cosine, and all of that, we can say that the sine is the y value and cosine is the x value because the radius is 1. So when the radius is 1, it doesn't really make a difference when you're multiplying or dividing by 1. But what these definitions should actually say if we're not using the unit circle, so if we have a value off of the unit circle, is technically that the sine is not just y, but y divided by the radius, right? Well, when we're on the unit circle, that's y divided by 1. So it's really just y. But when we're not on the unit circle, this radius becomes really important, right? Same thing for cosine. It's really x divided by the radius. Again, if the radius is 1, it doesn't make a difference. But when we're not on the unit circle, it's going to make a difference. Now, tangent is still going to be y over x, all right? So I want you to pause this video for a second and use the definition of sine and cosine, y over r and x over r, and see if you can figure out why tangent is still going to be y over x. So pause the video, try it, and then come back and we'll look at it together. So if we were going to find tangent here, remember tangent is sine divided by cosine. So here we have y over r divided by x over r. And whenever we divide by a fraction, we're multiplying by the reciprocal of the denominator. Oops. So these r's actually cancel out, and we still get y over x, right? So because they both are dividing by the denominator here, not by the denominator, by the radius here in the denominators, the radius doesn't really make a difference. So tangent and cotangent are the same as they always were. But more specifically, if sine is y over r, then cosecant has to be r over y, right? Again, here it's written as 1 over y because the radius is 1. But when it's not 1, that's going to become a problem. All of this is really saying the same thing as SOHCAHTOA, which is why I didn't really go over this before. If you think about making a triangle out of these things, here is, maybe my angle's over here. Here's my reference triangle, theta, right angle. So r is the same as the hypotenuse, right? X, this length of x is the same as the adjacent side, and y is the same as the opposite side, right? So to get sine, we could still do opposite y over hypotenuse, which is r. It's y over r, exactly the same thing. So really all of these values come from SOHCAHTOA, and if you know SOHCAHTOA, that's all you really need to remember to figure this out. All right, so that's a little bit of the why we're doing these values differently, is because we're not looking at values on your unit circle for the most part. We're looking at values that are on a circle bigger or smaller than what the actual unit circle is. And that requires us to use the radius here. So let's talk about the actual positive, negative sign values of the different quadrants. Well, in quadrant 1, right here, all of those values, the x is positive and the y is positive, right? So we know we have positive, positive, but remember those relate to different actual function values. So that tells me sine of theta, which is the y value, is positive. I'm going to write it as greater than 0. And cosine of theta is also positive. Well, if you think about how to find tangent of theta is going to be sine divided by cosine, so it's going to be a positive number divided by a positive number. Well, that's still going to be positive. So tangent is going to be positive in the first quadrant as well. In the first quadrant, everything is positive. And if we think about that, well, sine is closely related to cosecant. So that tells me that cosecant is also positive. Cosine is just the reciprocal of secant, so secant is also positive. And cotangent is the reciprocal of tangent, so that also has to be positive, right? So I'm just looking at the sine value of the points there. On quadrant 2, if we go over to the left here, we see that the x is negative and the y is positive. All right, so that tells me sine is still positive because that's the y value, but cosine is negative, and so tangent then is going to be sine divided by cosine, so positive divided by a negative, which would be a negative number. So tangent is less than 0 there. Now, the related values are going to be the exact same thing. So if sine is positive, cosecant is positive. If cosine is negative, secant is negative. If tangent is negative, cotangent is negative, right? So tangent and cotangent are negative in any of the quadrants where the points have one positive value and one negative value. So looking at quadrant 3, here our points are both negative. So sine, we know, is negative. Cosine is negative, but think about tangent. Now sine divided by cosine will be a negative divided by a negative, which makes a positive. So it's actually positive. This means cosecant is negative, secant is negative, but cotangent is positive. And then quadrant 4 is the last one here, and we know in quadrant 4 our points are positive and negative. So sine is negative, cosine is positive, and tangent is going to be negative divided by a positive, which is a negative. So cosecant is the same as sine, has to be negative. Secant is the same as cosine, has to be positive. And cotangent would have to be negative. So this little chart is going to be really helpful for you when you start to do some of the practice here. So first, let's see if we can figure out a few of these problems. All of these questions here, I want to figure out where is tangent positive and sine negative, and which quadrant does this happen? Well, if the sine is going to be negative, then that would leave us with, that's where the y value is negative. And obviously you guys can use the chart we just made above, but I'm just trying to think through it. So this is where y is negative, so that's going to be quadrant 3 or quadrant 4. And then where tangent is positive, that has to be in a quadrant where we either have both positives or both negatives, which would be quadrant 1 or quadrant 3, right? So it seems to be the place where tangent is positive and sine is negative is only going to be in quadrant 3. That's where that overlap would be. And you can see that here, sine is less than 0, tangent is greater than 0. So let's look at the next one. Cosine positive. So where's x positive? And tangent negative. Well, x is positive in quadrant 1 and quadrant 4, right? So 1 and 4, where x is positive, in here and in here. And then tangent is negative, where the values would have opposite signs. So where it would be a plus and a minus, or a minus and a plus. So that's quadrant 2, or quadrant 4. Well, again, the overlapping one here is the one that would work. So cosine is positive and tangent is negative in quadrant 4. All right. Let's just do a couple more until you get the idea. Let's try one with cosecant. So cosecant is positive. That means sine has to be positive. That means the y value is positive. So y is going to be positive in quadrants 1 and 2. And then cotangent is negative. Well, that would be where tangent is negative. And so that would be in quadrants where we have opposite signs, which is going to be quadrants 2 or 4. So again, the quadrant that works for both restrictions, cosecant positive, cotangent negative, is quadrant 2. So here we have cosecant positive, cotangent negative, quadrant 2. Okay, so that's the first step you're going to have to do when you're solving these problems. And let's just do one example together so you can see how to do this. So they're giving me the cosine is 8/17. And when I look at that number, that is positive. And the tangent is negative. All right. So we want to think about sketching this on a graph here. So which quadrant is cosine positive and tangent negative? Well, cosine is the x, so where's the x positive? And then the tangent negative is going to be where they have opposite signs. So cosine positive is here and here, and tangent is negative in quadrant 4. So we're going to draw this triangle in quadrant 4. That's where this information is true. So that means I'm going to sketch my reference triangle down here, and it doesn't really matter where you put it, just somewhere in quadrant 4. And then we always remember connect that up to the x-axis, right? There makes my right angle, so this is my reference triangle. And theta, or it's actually theta prime because it's our reference angle, is right in the closest spot to the origin. All right. Now, if you remember, cosine is adjacent over hypotenuse, or we can also think of it as x over the radius. So in my case here, it's 8/17, which tells me that the x value up here is 8, and the radius is 17. Now we want to think, do these values make sense? Well, the x direction is positive, so it makes sense that 8 is a positive number, and the hypotenuse is always positive. So that's something to remember. So then, how do we find the missing side over here? We have to go back to Pythagorean theorem. So 8 squared plus b squared is equal to 17 squared. 64 plus b squared is equal to 289. B squared then is equal to 225. So b is equal to, we usually would just say 15, right? But remember, when you're actually taking the square root, we get both positive or negative. So we have to choose which one we want here. And if you look at where this side length is, it's in the 4th quadrant, and the y value is negative here. So we actually want to use negative 15 because this is below the x-axis. This value here would be negative. It's going to make the point 8, negative 15. Right? And once you know your full triangle, well, we already have cosine, so then we can set up sine of theta, opposite over hypotenuse, so negative 15/17. Tangent is opposite over adjacent, so negative 15/8. Cosecant is going to be the reciprocal of sine, so 17 over negative 15. Cotangent is the reciprocal of tangent, so 8 over negative 15. And secant is the reciprocal of cosine, which is the one they originally gave us, so 17/8. All right, so give your